Total E&P Uganda began its operations in the Murchison Falls National Park in February 2012 following the farm down with tallow oil, in which it acquired 33% interest in Blocks 1, 2 and 3A under a joint venture partnership with Sinuk and Tallow Oil. Total E&P Uganda is committed to developing Uganda's oil resources with minimal impact to the environment, as the success of the project lies in our ability to respect and protect the environment. Total E&P Uganda has therefore invested in highly innovative technologies such as 3D seismic and drilling of horizontal wells, as well as employment of highly trained staff to ensure that operations are carried out with respect to the environment, wildlife and biodiversity.
As a biodiversity supervisor, my major role is to make sure that we implement a project that does not infringe on the rights of tourism and wildlife. 3D cableless technology has been chosen for Uganda because it takes half the labor and half the disturbance to wildlife and tourism as compared to the conventional telemetry cable system.
The 3D that Total E&P Uganda is currently undertaking is serving the purpose of enabling us to survey a wide area to develop very accurate positioning of all of the events below our feet, both in the horizontal and the vertical domains, to ensure full recovery of hydrocarbons. The 3D technology we are using for this particular project incorporates the use of cableless recording systems. This allows us to plant this in the ground and enable us to capture all the seismic data, pick it up and take it back to our camp for downloading.
When an area is suspected to be bearing oil, the only sure way will be to bring a rig and to make a hole in the ground up to the formation. There are four main important parts of a rig. The first part is the power system. This system provides all the energy we need for the equipment and the facilities on the rig. The second part of the rig is the hoisting and rotating system. The hoisting system helps us to pull in and out tools into the well and rotate the string in order to make the hole. The third part is the circulating system. This system drives a fluid in and out of the well, and this fluid helps lubricate and cool the tools that we have downhole. The fourth part of the rig is the well control system. This system helps us to close in the well in case we have an influx of formation fluid into the well bore. Drilling involves making a hole and securing this hole by running a string of pipe, which we call a casing, to protect this well bore from collapse. Testing starts after drilling. Under testing, it involves running a string of tools down the well and flowing a sample of the oil on surface to measure the characteristics of the reservoir and also to see the properties of this oil. A horizontal well is a highly slant well that is drilled along the inclination of the reservoir. If we have a reservoir that is below a water source, what we can do is we can place our rig at a faraway distance on land, and here we can drill a very slant section under the water source. This will enable us to reduce our footprint in the national park.
Once the drilling activities have ended from a pad, we restore the pad to its original state. We strip off the mudam from the pad. We contour the pad by landscaping the pad to original state. We bring the topsoil back to the pad. We discolor it and then bring the grass from the vicinity back into the pad by planting it and then watering it for at least 7 days. Generally, the restoration process takes between 5 to 6 weeks.
A restored site should over time regain its original status in the wider environment in terms of ground profile and vegetative status, after which wild animals should be able to utilize the location.